And let's get you cranking here with problem of the day. Today we're going geometry. A polygon has 20 diagonals. So how many sides does it have? Wow, that's kind of a crazy thought, all right? A polygon has 20 diagonals, so how many sides do we come up with? You know, if we have the number of sides, we have the same amount of vertices and also the same amount of angles that we're working with, but the diagonals are kind of a little bit tricky. So let's talk a little bit about this thing. There's a formula, and I'm going to go ahead and cut to the chase with the formula. Hopefully, you know, with calls coming in, we'll be able to move forward here. But and we'll look at the logic of the formula here before we actually work this thing out. If we take the number of sides and we take that number in and we subtract 3 and then we divide by 2, we get the number of total diagonals. Now you say, where in the world does that come from? I agree. A lot of times we want to ask. So let's just go back and play with this a little bit here. I've got my little ruler. We'll draw a few little pictures, maybe some things, and then we'll see how this works to get us the answer here, all right? And where did it come from, so to speak? Well, let's see. First of all, if we start with a triangle, I think everybody can figure out there are no diagonals in a triangle. Do I need to draw a triangle? No diagonals, all right? So let's go to the next piece here, which, by the way, guess what? If we put 3 for our n, the number of sides for a triangle, 3 times 0, well, that's 0. So we're off to a good start. And by the way, if you divide 2 into 0, you still get 0. Some of you still think it's 2. Nay, nay. All right, don't do that. Let's talk about, just some sort of rectangle, square, 4-sided figure, quadrilateral. Doesn't have to be pretty. Probably won't be with me drawing it. It didn't come out pretty well, but it's still the same process. All right. And we're going to pick how many diagonals are there in this picture. Well, right there's one going across. Remember, diagonals are not sides. They're the line segments you can draw that are not sides. And here we go. And it looks like I see 2. Now let's put that 4 in here. 4 for n. 4 times 4 minus 3 gives you 1. It really is a 1 there, folks. And we'll divide that by 2. 4 divided by 2, that gives us 2 diagonals. I see 2 diagonals I drew into the picture. All right? Let's play right on up with the good old Pentagon real quick. 5-sided figure, and again, I don't guarantee it's going to look pretty, but it will be 5 sides, and we can play with it. We'll try to stay above my little register there so you all can see the call. And bring it right around here. Boom. Now, we got a few more diagonal situations that we can draw here. But what I want to start to notice here is from this point, remember we talked about our vertices? From this point, each of these points, how many diagonals can we actually draw? Now, there's a side, there's a side. Remember, they don't count. So from this vertex right here, we're going to slide it off here, and we're going to slide it off here. That's 2 diagonals per vertex. Now, I come back up here, do the same story. I've got 2 diagonals. Well, let's see if I can get it to there. Here we go. 2 diagonals per vertex. Boom, boom. Well, guess what? Every time, if I have 5 each vertex, it seems like I'm coming up with 2 less diagonals from each vertex, right? Actually, not 2 less, but 3 less, because I've only got 2 left over here. Now, remember over here, we ended up with the n minus 3 pretty well also. If I left, I've got 1 more, don't I? Let's take this vertex. And wait a minute. We've already drawn that one, haven't we? That's going to be an interesting problem. We'll go to this vertex. We haven't played it yet. We draw it here. It's already drawn. It's already drawn. Go down to the bottom down here. We're already drawn. So it looks like we have drawn from each vertex, we've drawn 2 diagonals, but they're overlapping. You kind of see this star going in here in the middle. There's 5 diagonals. 5 diagonals. So again, let's take a look at that. If we got 5 times 5 minus 3, that would be 2. That's 10. And divided by 2, we're back to our 5. So this formula is working. Now, why do we use n minus 3? Why do we use n minus 3? And, by the way, why do we use that 2? The 2 is for the overlapping. 2 is for the overlapping. The n minus 3 basically says we are losing each time 3 basically pieces that we think from the vertex because we're only able to write like we're going to go 2 there. If we did a hexagon, we'd be only to do 3 diagonals from each side. So there's an n minus 3 pattern that's building there. So now let's cut to the chase here, and let's see how this works with our little problem. Using this formula, which we'll establish, And again, the divided by 2 is very important because every one of these times that we drew the 2 here or whatever number we're going to have, we're overlapping, all right? And that takes out half of the amount. That's why it's important. So let's play it off the 20 diagonals. Let's do it. We've got n times, we're going to use algebra. You got it. Everybody says algebra. Algebra and geometry, they go well together. That's why you take algebra the year before you do geometry, my friends. Now, let's play it out here. This is not a hard problem. This is going to be pretty straightforward. I'm going to play proportions, and we're going to work it n times n, and n times we're going to take n times the negative 3 in there, and distribute, which is going to give us n squared minus 3n. And I'm going to go ahead and cross multiply. So really and truthfully, while I'm distributing, I'm also going to cross multiply, save us a little bit of time. And I've got 20 times 2 on the other end, I've got 40. Now we all know, if we've got a situation like this, and we hope it'll factor, because if it doesn't factor, we don't have a number of diagonals, all right? We've got to have numbers that will factor here on this. So let's set this thing equal to 0. And we've got n squared minus 3n minus the big 40 equaling 0. And if I'll drop out my bottom there for a little bit, we'll break this thing open. Well, ask for something, they give it to you. Thank you, guys. We got n, and we got plus, and n and minus. Why did I get n and n? Because n times n gives me that n squared back here. We're looking for binomials here that are going to basically multiply together and get us back to n squared minus 3n minus 40. Now, how do I get 40 on the end? Well, I've got a lot of ways I could do that. I could do 4 and 10. I could do 2 and 20. I could do 1 and 40. But the one I really am wanting to think about is 5 and 8. Now, why do I choose 5 and 8? And one of those has to be negative. Well, because I need a negative 3 back in the middle. I'm looking for values that if I would go first, outer, inner, last, to FOIL or multiplication, however you want to look at it, I should come back with a negative 3 in the middle. And if I put the value here, let's see, what do we got? I said 8. Where's 8 going to go? Well, it's got to come out negative, right? Because you're going to have a negative 3 in the middle. So there, we're going to work there. We're going to put our plus 5 right there. Now, game's not over yet. Sorry about that, guys. We're still almost done. N plus 5 equals 0, or n minus 8 equals 0. Look at what was going on here. So I could say n equals negative 5, which makes no sense because remember, these are number of sides. Over here, I will say n equals 8, which makes a lot of sense. All right? So say goodbye to that one. Keep this one. And let's check it out. If we have an 8-sided figure, by the way, it's an octagon. All right? How many sides does it have? That's 8. In the formula, 8 times 8 minus 3 divided by 2 equals 20. We'll do a quick check. And that's going to give us, looks like, what? 40 over 2. And does it give us 20? Yes, it does. Checks out. So when you're working through this problem, by the way, it's over a 2 there. And if you're working through this problem, what would be nice if you could draw a good old stop sign, right? That's what an octagon is. Just do that and test and see if you get 20 diagonals back in that. It may take a little bit of a while to work with it, or just work the formula out as you go up the ladder. Go up here with 3 sides, 4 sides, 5 sides, 6 sides, 7 sides, and then get to 8 sides, and you will be at 20. Pretty cool problem. Thank you.